Yeah. So, all right. Well, since I'm seminar director, I get to introduce myself. Well, Tim, welcome back. I've invited you here to help me celebrate a long career in Biosystems and Agricultural Engineering. I hope this is going to be a fun seminar, but I also hope that when you look at the perspective of my career from the beginning to the end, especially you grad students, it might give you a little bit of vision about your own career. So hopefully you can look forward and enjoy this, and then toward the end I have some philosophical things that bits of philosophy I want to extend to you. I think those are some that I used in my life, and maybe, you know, if they work for you, maybe you can take some of that home with you. So, okay, and just like the graduate students, we have an outline. My outline is chronological. It's pretty much going from before I came to the university all the way through, and then I have a projection of where I think I'm going, and then my bits of information. So the only place I get off of the chronological is the fun times here. So this is the old days. I was born in Hardinsburg, south of Hardinsburg, Kentucky. It's 145 miles. And this is a house. I was actually born out on a farm.
Wow.
So,
was that on purpose?
That was, well, my dad took my mom to the hospital, and he said she wasn't ready. And by the time she got home, it was too late. So
that doctor was wrong.
Yeah, I know. This is just a typical Rolling Hills, Western Kentucky farm. And there I was in 1951. I've tried to put the dates down here on most of these. And that was...
You went too fast there.
Yeah. And that was our family, a family farm, 1954. Myself in grade school, high school. Of course, we had the flat tops. That was popular. That was part of the, you know, the GIs coming home after the war.
Glasses are kind of back in.
Yeah. And then I did away with the flat top somewhere around getting out of high school, and then there was I had a big decision to make, and I was very fortunate. My dad gave us, my brother and I, 2/10 of an acre of tobacco to raise, and we saved our money, and I had close to $3,000. This was back in 1960 or 1965, which is a lot of money, and this car was going to cost $2,700.
Really?
Oh, yes. So this is me. I had a pocket full of cash, and what was I going to do? And I decided, yes, I'm going to get this car. And I told J.C. Blanchett, he was the owner of the Ford dealership in Hardinsburg. I said, I want to buy this car, and he said, well, let's go down to Ruby McCoy's restaurant. It's one of those old-time restaurants with the bar stools and the seats along the side, and we had a cup of coffee. And to make a long story short, he talked me into going to school rather than buying a car.
Fred, that's a nice car. I think you made a mistake.
I still haven't got that car yet, so, but maybe. And the price has gone up too. So, but 2 weeks later, he had connections. He got me into Western Kentucky University, and I went into business administration. That only lasted one semester. But no Mustang. This is the only picture I have of the Pinto that I got, okay? But that's, anyway. So then, I guess my real career here in Biosystems and Ag Engineering started somewhere around the 25th of August, 1966. And that's I had heard about having a program called agricultural engineering. So I'd said, well, you know, I'm from the farm. Maybe that's for me. So I went into this building. This is the old ag engineering department, and the Kelly building. I talked to Jerry White there, and so you know, that was, you know, my heart's been here since. So, and I was part of a large class, and that was, I think, part of the baby boom generation was. And there's, I guess, other dynamics, but there's several people here that have had an impact on this department. Of course, Carl King, there's Doug Overholtz, David Ludwig. He unfortunately had passed away, but he left something like $300,000 for our scholarships. And you know Larry Wells and Frank Wiesty. And of course, he's donated a scholarship, and that's me sort of hiding back there. And then after that, you know, we all make different decisions about going to grad school. And I've always said, in our recruiting, we can compete with anybody except a boyfriend or a girlfriend. And so I know that from personal experience that that's true. But this was the reason I went on to graduate school. And so I've got a very few slides of my master's, but I did start, and this is part of my work with Joe Redwine. We were out in the lab, we were doing stuff, there was a student, PhD student for Dr. Ross Harvey Hamilton, and his goal was to take chicken manure and take the urea, that's a non-protein nitrogen, and convert it by microbial digestion into protein nitrogen. So that, and I was involved with him, helping him. And then my project was to try to sterilize the chicken manure. And of course, I wanted to get into food engineering, and this was sort of a project that Dr. Ross and I worked up. And so this is the system. I designed something for the old Instron in the other building, and below this, what I have is a brass. The only thing I couldn't replicate today is the smell. Okay. Thank you. You can see the heat, and it spit and sputtered, but it was from a technical standpoint, it was plug flow with a brass heater around the side, and you can assume nice radial heat transfer, and it was a nice engineering problem. And so that's, and we looked at the sterilization, you know, from a dynamic standpoint. So that was my master's, and I wanted to leave and go into work for General Mills, or for a company, and I was fortunate enough that General Mills hired me, and I worked as a project engineer in their plant in Cedar Rapids, Iowa, and they were manufacturing meat analog products, and this was the time of the energy crisis and the hamburger helper, and so they were using some of the extruded soy protein products for hamburger extender, and so this was a neat process that we were extracting the protein and forming fibers and making artificial ham and chicken and other products. This is a simpler product, it's just extrusion. And along the way, one of the things that General Mills did was they took their process. Some of you older guys may remember some of the commercials about Cheerios and wheat puffed from guns. They actually used to puff it from guns, but that was massively uneconomical. So General Mills developed a continuous puffing system, and it was a steam puffing system, and I'll show you on the next slide how it worked. But basically, you had to get pellets somehow into a steam atmosphere, and this is they've got a rotary valve. It's about 14 inches, 16 inches wide, 8 or 10 inches in diameter, and they call it a pocket valve, but you drop material in this pocket, and then when this rotates over, this is in a sealed brass. There's the seal between this. This is under compression, and somehow it seals. It's a metal to metal contact. And then when it rotates over this way, the steam pushes that out. And so they had converted that for making textured soy, but that's exactly how they get the Cheerios pellets into a steam atmosphere for cooking. And they're still puffed that way, I assume. So it's been many years. But anyway, that was from a technical standpoint, I really enjoyed working with that process. And then I left General Mills, had one kid, come back and was working on an energy project. This was after the oil embargo. The price of LP gas was just astronomical. And so the farmers were really complaining about what can they do. Can they use something else to dry the grain? And so that was my goal, was to try to see if we could find something else, an alternative energy source for drying grain. And so I looked, and we developed a prototype gas fire. Bob Brashear, Bob back in the corner, was an undergraduate student, I think, undergraduate at that time.
No, I graduated and was in graduate school.
Okay, so but he helped me build this, and so that was starting here. Him and Dr. Ross were my supervisors at that day, so they helped. But anyway, that was the start. You had to get your feet wet, and you guys, when you look at a project, you're trying to explore out into the unknown. Sometimes you just need to get your feet wet, and that was the purpose of this. Let's just see what we can do. And then this was the second prototype, and then this one we were trying to automatically feed the biomass into a burner. And the burner is a two-stage combustion. I'll show you what it does in a moment. Our corn cob was our fuel source was corn cobs, primarily because they had superior handling characteristics. You could handle them. The corn stalks, you know how they are. They're not easily handled, and so that's why we chose that. This is the technology, and we have biomass in a gasifier, and what we're doing is the same thing as happens in your fireplace. If you throw in a piece of paper or something and you see, it's going to flame a lot. Well, the first thing it does is smoke. The smoke is the pyrolysis gases. And so we're deliberately trying to produce as dense a smoke as possible. Now, I used to use the example too of a cigarette. If you hold a cigarette up like this, you'll see a stream of smoke going up. You can take a match and put it right above the smoke, and you can burn the smoke. So that's what we're doing here. We're starving this. There's little or no oxygen here. There's a lot of white smoke going over. Then you go into a second insulated combustion chamber. You bring in air and you burn it. You get a clean exhaust, a really clean exhaust, and you mix that with outside air, and then you can use that for grain drying. So that's the concept, and that's identical for all the next slides you see. I'm not going to go over this, but that's exactly what we were doing. And this is the only picture I have of my my PhD apparatus. But we built this, and Bob helped, and it's that little building over next to the shop. It used to be an incinerator for the medical center, but they weren't using it, so we cleaned it out and we put this in there. And so I run my PhD experiments there, and I finished in 1979 with that. And some of the other, I had other help. I don't have a good picture of you, Bob, but this is Frank. So he was hired to help me with this. So And then, of course, this project went on. Bob got hired by a company called Clayton and Lambert. Where are they located, Bob?
In Oldham County.
Oldham County, Kentucky. And so they built a commercial version of this. And I think there was 4 to 6 of them sold. And, but I wanted to show you the startup of this. I have, we start off, this is the pyrolysis gases, except they're diluted because we use, we use a fan as an eductor, like a venturi, to pull a suction on the whole system. So this is diluted with that secondary, or the fan air. When you get ignition inside your secondary combustion chamber, you know, you don't see any more smoke. And then the next picture, I'm going to look right down in that, so you can see the glowing red. So that's, and you see a nice clean exhaust coming from that. So, and I think the department, Dr. Parker, used that, and they worked with a Stirling engine. I wasn't involved with that, but I think the department worked on trying to adapt a Stirling engine to that. Then I left for Clemson, South Carolina after that as an assistant professor position. Had 2 kids that were part of the move. This is, they had a really nice building. They still do. This is McAdams Hall. It's just an extremely nice building. And this is my office down there. But I do have to ask you, I asked this one person, they figured out what was missing from the office. You got any guesses?
Computer.
Yeah, this is before computers. My electronics, I think, consist of a handheld calculator.
Which is probably $100.
What's that?
It probably cost $100.
Yeah.
It was way more than $100.
Oh, yeah, that was probably a $150 or $200 buck.
Yeah.
But that was the extent, and of course we had the rotary dial telephones. So it doesn't seem like it's been that long. So, but my first challenge was wood chips. And so we had it's the same concept, wood chip burner, you gasify it. The only modification was a cyclonic combustor that was trying to eliminate some of the sparks that were coming out. And then we went off in a way that you could get the heat out for different purposes. This is the system I built. And the courtyard here, when we, they had a really nice courtyard. And when we designed our building, I was one of the guys that said, oh, we need a nice courtyard with a wall around it. And the only thing, they can lock theirs, we cannot lock ours. So that was a little bit of a difference.
So they must have had a shop.
Yes, they did. It was right beside there. And then this is the system in operation. It's the same process. And okay, now the real challenge was down in there. They used a lot of heat to cure their tobacco the flue cured tobacco, and they used cordwood. So they wanted to know if we could build a cordwood gasifier combustor. So I started on that, and the concept was to have something that you could put cordwood in and burn it, and then get the heat off. And then you would take that heat, you could have a storage tank, and then go to the different barns for curing their tobacco. So this is my first version of that, and it does. This is when you're starting it up, and it smokes a lot. It looks like, well, boy. I called the fire department there too to make sure that they weren't going to come. So, but after you got started, you know, it was clean combustion, and so it functioned. And I put that in a farm down in it was near Edisto, South Carolina. It's pretty. It's down in that Myrtle Beach area. So. Then in 1985, a position, Dr. Ross asked me if I would interview for a position here at the University of Kentucky. And so I said I would, and of course I accepted a position. I had now 3 kids with unbelievable amount of toys, you know, the big wheels and all that stuff that takes up a lot of space. But I arrived in the fall of 1985. It was August of '85, and my family they didn't come until the spring of '86. But I stayed with Richard Warner for 3 months, so that you might know that he's not here. I had something in here special for him, but
Show us anyway.
yes. Well, so
Be careful when you say.
yeah, that was an experience. Then one of my first projects, and is Joe. I worked with Joe Taraba some. He's a chemical engineer. We figured out all the reactions, but I was searching for a nice project in food engineering, and people were complaining about the high cost of freeze-dried products. They're extremely expensive. I said, well, maybe we can puff them. I've got experience in puffing, but the uniqueness about this is a low temperature puffing. Everything I dealt with before is high temperature, steam, it's water going from a liquid to a vapor. This, you can't heat the vegetables, so you have to puff it at a lower temperature. So what we were doing is taking green bell peppers and the different things, and we would dry them down until approximately a 30% moisture content. So they're nice and pliable and soft, and then you pressurize it. And what I was doing, I was taking a liquid CO2 tank, and so the pressure is going to be about 1,000 psi. It depends on the temperature. And you put your say diced dehydrated peppers in here, and this is what Joe helped me with, was the dynamics of absorption. You have absorption into the water, and there's a reaction with the water. It forms carbonic acid, and then it adheres to the surfaces. Adsorption, absorption, all of those. So we worked through that, but it took about 3 minutes for that to come to equilibrium, maybe more for different products. And then what you would do is shut off this valve, and then I had a ball valve there I would open, and I estimated in something like 90 milliseconds you're going to go from 1,000 psi down to 0. Okay, and it sounded like a shotgun. So it was probably wouldn't pass OSHA inspection at all. But this is carrots, puff carrots. This is before and after. So it would work. This is the green bell peppers before and after, and tobacco stems. And along the path, I learned that the tobacco companies actually use a different version of this to puff tobacco. Cigarettes are sold on volume, not weight, guys. So, but yes. So if you puff the tobacco and make it bigger, you use less tobacco in a cigarette. And this is a tobacco stem. They puffed extremely well. And the potatoes. And you're really in luck. Here's it. This is the date on this is 5/23/91. Okay. They've been in my office forever, but I'm just going to pass them around. If you want one, I'm cleaning up my office. Feel free to take one a piece and just don't throw it at me. But just pass it around and take a piece. That's what it's there for. So don't eat it. I thought that's what it is. So no. And then. Yeah, we'll get a little bit off the chronological order here, but most of this has happened in our department. We've had a lot of good times, and
oh my gosh!
This was one of the parties that I helped organize. Well, but George Day and my wife did all the work. They added nice touches, but we had a Long Branch saloon party. and that was March 1st, 1987, and it was over in the Good Barn. So I don't know what what they were doing there, but that was George and Tim. This is my wife, and Joe Ross and Tim had a deal. You know, they both survived, but we had a gambling table. This is Larry Turner, Jeff McNeese, my wife, Bill Barfield, Donnie Culver, and Daniel Saputra, one of my students. So that was.
Why does Don Culver have a hard hat on?
Maybe he thought it was a YMCA club.
And then this was my wife. She was. This was actually at my home. I I just wanted to throw that in there. So, and we had there are other good times here. Jane. This is Jane and Jennifer. You know, I'm leaning on them. What I meant to say there is, you know, I've had excellent support from our. It used to be secretarial staff, and now it's our staff assistants. So.
This was before or after the dress code letter came out?
So, but I think that was, I don't know, that's fall of '99. So, and then I've had several trips. I didn't put it in here, but a lot of, because of the milk coagulation work center that I've got, I have been invited around several places. I did take a sabbatical to Spain for 2 months. It was only 2 months, but I told him I had to see a bullfight, and so this was not only my first, but it was Manuel's and Emma's first too. And then later on, Manuel came over, and he was assistant research faculty member here, a very productive faculty member, and I'm still working with him now. So that's been just a fantastic relationship. And by the way, he's a food scientist. I'll bring this up again a little bit later, but he's a gentleman that should have been an agricultural engineer, but he's a food scientist because he likes the engineering part. So we complemented each other very well, and I've had fun times with students and different classes. I've been to Wild Turkey 20 times. That's Czar, yeah, and that's Czar. She was a PhD student. Daniel was one of mine, PhDs.
Molly and Tim.
And yeah, let's see, Grace, yeah. So, and I've got others are graduate students. This is Molly, Sam,
Nazrin and Emily and Pam.
Yeah. So but that's just the pictures I have. There's many more. There's a lot of students I have no pictures of at all. I haven't been good at getting those. But Zara she was a fun student and a nice student. This was a long time ago too. So one of the other good times we had was when we had the 50th reunion. And those that you attended may remember Mike Bushermole there. Boy, was he comical. He was comical. We had a blast at the 50th reunion, and one of the places I was invited was to South Australia, and the gentleman there, we took off on a Saturday and went down to the coast to visit the coast. That was in August, but boy, it was cold. You know, that's their winter, and. But that was, and then of course I've worked with ASABE and done different things. But this was we had a foundation dinner a couple of years ago at ASABE. This is Steve Buttleman. He's the bugler for the Kentucky Derby, and he came there and played in my old Kentucky home. And several of the ladies bought hats and came dressed up. So that was a lot of fun too. Then. This was Claire Hicks that came yesterday, and he's teaching right now and couldn't make it today. But you know, I was searching for projects to work on, and so he's a food scientist. I asked him, "Do you have something that I can work on?" He said, "Yes, I do," and it was involved with cheese making, and you know that's that's been a major change for me, because I enjoyed the work, and I've just been thrilled to death with going down the path that's led me. So that was, you know, a few people have made major changes, or changed the direction of your career. You know, the J.C. Blancett not selling me the car, and say Jerry White, whenever I visited with Jerry White, and then and of course Joe Ross helped a lot, but this was a major change for me. So, but I'm gonna my work was in going from milk to a curd, and that's a 30-minute process, and I've got some details on that. But that's I developed an optical sensor that would help automate that process. Later on, when I talk to you, I don't hold this back in your memory, but Manuel and I worked on syneresis, and what is the syneresis is when the curd, after you cut the curd, it's going to shrink, and you can see 7 minutes, 17, 36, and 48. It goes from a liquid, it goes from a gel down to a two-phase of whey and curd particles. Well, the whey is now 95% of the volume. So how are we going to monitor that? Well, the technology I'm going to use is just use your eyes. You can see it. And so we developed a non-contact sensor, and so that's we actually already have a patent on that. We used a camera, but that's a technology that I hope to implement. And so that's a syneresis, and then I've got we're looking now at some fluorescence and other ways of detecting the protein and the fat content in that liquid. And so, and then there's another one here that I worked on. It's intelligent systems for telling the operators how how much enzyme to add, because the operators are always trying to figure out how much enzyme. It's the throttle. That's the one thing that the operator does. He's in control. How much enzyme, and that either speed it up or slow it down. So there's an opportunity there to add that. So my work first is in this region, but when I tell you about what I'm going to do in the future, it's putting all of those together. So again, that was syneresis. The optical technology is to shine infrared light in here and pick up the reflectance. And the infrared light, what it does is the milk is made of little bitty casein particles, casein micelles, and after you add that enzyme, in that 30 minutes, the enzyme starts clipping away at the protein linkages, and it destabilizes it, and then the proteins start cross-linking with calcium, and you finally get a gel, or you get agglomeration. Those particles, this will not reflect very much infrared light. This reflects a lot of infrared light. So what happens, this is the curve that I measure. So you go through that 30 minutes, if you look at how much infrared light you reflect, it jumps up like that. And then it stabilizes. So what I do is take the first derivative of that, and you can pick off this time here. And this time here, between adding the enzyme and seeing that, is an exact measurement of the kinetics, the enzyme kinetics. So we're able to, with an optical sensor, measure enzyme kinetics. And this time is extremely correlated with that. And so that's the heart. It took me 5 or 6 years to figure this out, but when I saw this correlation, I said, well, that's a technology that can be commercialized. So we did. The UK got a patent on it with Claire Hicks and I, and then we started. The next phase of the project was try to get it implemented. So I worked and developed a little system for implementing in Glasgow, Kentucky. and it was a little, the plant's down there, but they don't make cheese there anymore. And this board had an LED and a photodetector, and then we took the optical cables here, the orange cable, and we strung it over to the cheese vat. Okay, that was not a good idea, but that was where I started. That's getting your feet wet. And this is video. She helped. They were strung. The cables came into here, into this computer. It was a computerized system, automated system. It didn't operate their system, but it gave them a nice picture of what was going on. And then this, on the other end, was this is a cheese vat and a probe that we stuck in. And all the probe just had the two optical cables, one sending out light and one picking up the reflectance. So that, to give you sort of a history, I tried to commercialize it and I started a company. The history here is 1991. We put the system in, that system in Glasgow in '92. They liked it so well they wanted one for Greenville, Tennessee. And so I made one for that. And this was through UK projects. And then in '93 I started the company Retrospection. Also that same year I sublicensed this to Damro. It's a cheese vat manufacturer that was located in Fond du Lac, Wisconsin. The history of that in a nutshell is they had it for a few years. They were purchased by GIA in Germany. They sold it to Sherping Systems in Minnesota, and then it got sold to Tetra Pak in Sweden. So it's you know, it's now Tetra Pak. It's not going to go anyplace now. I don't think, but that's the history of that. And for me, it's more of a hobby than a company. It's still a one-man show, which is unfortunate because it doesn't have vitality. I mean, you can't. If I get sick, my company gets sick. You know. So, but in the meantime, from '93, this is the ones that we tried out in Wisconsin, and they said, just the sensor, please. They didn't want the computer. They just wanted a sensor. So this was my second version, and I have a board there. I put all the electronics, and they said, just give me a 4 to 20 milliamp signal out, so, or 5 volts. So, but then along the same time, that board cost $700. There was Taos came out with a little chip, cost $2. I had no choice but to redesign and simplify it. So we did that, and then I was testing over in Ireland, and I figured out one of the problems. It was vat wall cooling. The cold wall on the vat was interfering with the signal. That I could explain that later, but I redesigned, and then plastics are not a good robust design, so I redesigned again, and then the latest one that's really has helped is going with the sapphire window. So I'm hoping that it has some stability now. As far as what, you know, it's a company. Somewhere around here, you know, the average, I've sold about 6 or 8 sensors a year. It's just enough to keep a company going. But I have had 2 good years in the last several where the sales went up, and I don't know that it'll hold, but you know, I hope it will, you know. So, but it's been more of a hobby than it has been a profit. I drive a 1999 Audi, okay. So when I show up at a 2014 Audi, you know, maybe I'm doing better. I don't know. So we did have another thing. You know, you don't know when these people are going to change your life. And this is Chris Thompson, and he came over in May of about May 10th, 2005. and said, yeah, there's all this noise about this money from Homeland Security, and he said they wanted a proposal, and we had to submit it in 2 weeks. And so we did. We scrambled to get something together, and you know, that has resulted in about $3 million for our department. So that was a good move. I don't want to explain all this to you, but it's the system that we developed was totally automated data collection. There's a security system that we developed for the truck that would secure a truck, and then all this other was the data collection with barcodes, and so that you could actually divide it up into 2 systems, and currently there's no interest in this commercial, and likely would never be because it's so expensive. But anyway, we did a good job developing it, and yeah, this is what went into securing the truck. We had locks, a lock on the dome and a lock on the rear, and temperature sensors, and then we had our communications, GPS and Wi-Fi, and the cell phone. So this is just a couple of pictures of that truck and the system. I actually have a prototype system down in the lab, and that's the truck that we used. So, and Brian Luck, I have to give Brian Luck a lot of credit. Brian was working on a master's degree with Scott Shear, but he really progressed on this and became the project manager. This was quite a large project. So, in summary, you know, we did a good job, a good technical job in developing a nice system, but the commercialization has been just impossible because of, I tell people there's no buyer. There's 3 buyers. If these guys would get together, those 3 groups would get together, we would have a buyer. But it's not. The dairy industry is pretty fragmented. There are a couple of places that are vertically integrated that have some potential, but for the most part, yeah, I don't know. That's 5 years of hard work. I would like to see something come out of this, but I haven't given up hope yet. But you know, it doesn't look really optimistic. The one slide here that you've heard from in our seminar from Jennifer's talked about her extraction of microorganisms, and Sam's talked about the concentration of microorganisms, and Steve's talked about the hyperspectral imaging. So that's that project is pretty much complete, and so now I get to look, you know, where am I going, and so I hope to still contribute to the department. I'd like to implement some of the technologies that I talked about on cheese processing, and there's a real opportunity for me with Tetra Pak, the Swedish firm. They're redesigning a vat of the future, and I'm meeting with them to talk about the automation. And I've told them there's about 4 levels. There's actually 5 levels of automation, and you go from you have to first automate the coagulation and the syneresis, and you have to have an intelligent system for determining the enzyme, and then you have to have a system that's optimized, and then you need a learning system. Those are probably, you know, that would take you down the road 25 years maybe in developing all that. But I hope to have some input into that. Of course, I want to spend more time doing what I want to do with my friends and family and my hobbies and crafts. So I do have 2 grandkids now. This is, we're trying to bring them up with the right color. Okay. This is Luna, and then that's Rain. And that's my daughter Melissa, my wife Pat, and Brent. And some more pictures of Luna and Rain. So. And finally, that's, you know, I've told several of you, and I guess I talked about it yesterday with regard to the 3 phases of retirement. There's the go-go, the go slow, and the no-go. So it's my goal to be excited during the go-go and to cherish the go slow, because you know at that point, yeah, things could happen. And then if there's a no-go, just be happy in that. So, and some bits of philosophy for you. I hope maybe this will help you endure all these pictures. But I do believe, from a professional standpoint, that your most productive research will be interdisciplinary. We are, biosystems engineers or biological engineers. There's the biology part, there's the engineering part. We tend to be really good engineers, and we tend to be really bad biologists. And so when we team up in any of our areas, I think that's when we can be most productive. So I really believe that. And I've seen this coming, and I've projected it. The amount of data that you have to handle is just going to explode. And so we have to, my advice is to keep updating your toolbox, because the amount of data and the efficiency demands on everybody is going to increase. The other thing I've seen is the options for orchestrating your teaching and research just will increase dramatically, just the same. You know, there's so many more tools, so many more options. We have LinkedIn and all those, YouTube, etc. So, okay, the other thing is you need to be smart, okay? It's not how hard you work, it's what you work on hard, okay? So that's, if you look at that, you know, we can all get busy. We can be really busy. And we all have a tendency to get really, really busy. But you need to be smart of it, about what you choose to work on hard. So I don't know, I just give you that as a bit of wisdom. So capitalize on your strengths and avoid your weaknesses. Some people would say to work on your weaknesses. But I know my strengths, and I have some really dramatic weaknesses. One, probably the biggest is memory. You know, I'm a good logical person. I make a perfect engineer. But if I'm going to try to remember something, you know, it's difficult. Remembering names is difficult. My wife is the opposite. You know, she can remember the microorganisms and what microorganisms are gram-positive and gram-negative. Oh, that's beyond me. And so I try not to get into those areas where I'm not good at. I try to stay where I'm strength. And I don't know, maybe will be of some help. And I have one last bit of wisdom, and I didn't develop this. My mother gave it to me. She had a 6th grade education. You know, walked over the hills and 3 or 4 miles, and quit at 6th grade. But she was really bright, and there's only one person in this world that can make you happy. That's yourself. So she lived like that, and that was, you know, I've learned from that yeah, happiness is something that you create. So it's not something that somebody else is going to do for you. So with that, it's a happy ending. So thank you guys for listening.